Hi everybody! In this video we're going to be talking about the word equivalence and how it relates to these two words of statements and expressions, okay? And what you'll probably find is that you've been dealing with equivalent statements and equivalent expressions since you started algebra, and hopefully this video will help you to put some pieces together. Okay, let's start with some definitions. So first, what are equivalent statements? Well, equivalent statements are statements that will have the same set of solutions. And equivalent expressions are expressions that will always have the same value. Okay, let's start by looking at some equivalent statements and a couple statements that are not equivalent. And if you're feeling uncomfortable about any of the solving that's going on here or any of the evaluating of these expressions, go check out some other videos before and then come back to this one, like solving one-step equations or solving two-step equations or even solving multi-step equations. And then you'll be able to build up some of the background knowledge so that you'll feel more comfortable in this video. Also, you should check out, if you're not sure about the difference between statements and expressions, go check out statements versus expressions, and in that video I can go into a little bit more detail about the differences between statements and expressions. But for now, I think it's important to realize that statements are true or false, expressions have a value. Okay, so that's the big difference between the two. Okay, let's start looking at some equivalent statements and some statements that are not equivalent. So here we have 2x equals 10 and 4x equals 20. And based on our definition of equivalent statements, these two statements are definitely equivalent. They have the same solution. Each one of these statements only has one solution. In other words, it only has one value of the variable that makes these statements true, and that value is 5. So 2 times 5 is equal to 10, so the value of 5 makes this statement true. 4 times 5 equals 20, so the value of 5 makes this statement true. And 5 is the only number in the entire universe of numbers that makes this statement true and also this statement true. Now, how we can show that these two statements, so we know that they're equivalent, but we can actually use a property of equality to make them identical. So for example, this equation right here, if we use the division property of equality and divide both sides of that statement by 2, we will get an equivalent statement to this one, which says that 2x equals 10. And now you can see that this one and this one actually are not only, they're identical now, but they were equivalent all along because they are identical. Okay? And that's what the properties of equality do. They create equivalent statements. So you start with a statement like this one, very complicated looking statement. I don't know what the solution to it is, but if I can create simpler equivalent statements until it's so simple that the solution is staring me in the face, then I know what the solution to the original statement was. So the idea is, okay, how could we transform a statement like this one to make it simpler so that we can see what the solution is? Well, we could start by combining 5x and adding 5x and 2x to make 7x. So we could get 7x plus 7 is equal to 8. Then I could use the subtraction property of equalities to subtract 7 from both sides of this statement. And when I choose to do that, when I'm using this subtraction property of equality and subtracting 7 from both sides, what this is going to do is this is going to create an equivalent statement to this one. So in other words, the statement that follows from this one will have exactly the same solutions as this one does. And that is what those properties of equality do. Okay, so now we'll have 7x is equal to 1. And now you can see that with using a few transformations of this statement, this one and this one are actually identical to each other. So this statement and this statement were equivalent with each other from the beginning. They have the same solution. And the solution happens to be 1/7. Okay? Okay, now let's look at a statement or some statements that are not equivalent. So here we have x squared is equal to 9, and here we have 2x equals 6. All right, so if I use the division property of equality and divide both sides of this statement by 2, I'll get x is equal to 3. Now in this equation, 3 is the only value of the variable that will make that statement true, the only number in the entire universe. But this statement has two solutions. What number can you multiply by itself to get 9? Well, you can multiply 3 by itself to get 9, or you can multiply -3 by itself to get 9. So either x is equal to 3 or x is equal to -3. Now, you might be thinking, okay, well this says x equals 3, the solution to this statement is 3, the solution to this statement is 3. However, they don't have exactly the same solution set, because although they share a solution, this statement has two solutions and this one only has one. So they are not equivalent statements. All right, let's look at a few equivalent expressions and some expressions that are not equivalent. And just a little reminder that statements are true or false, expressions only have a value. Okay, so we can show that these two statements are equivalent to each other by using the distributive property. So if you distribute 2 to both of these terms, you will get 2x plus 4. And we can see that 2x plus 4 and 2x plus 4, those are identical expressions, right? So we know already that these two expressions are going to be equivalent to each other because they will always have the same value. And we can just kind of like test out a few numbers to see how it's working. So if we choose, let's say, x to be, let's choose x to be equal to 1. So if x equals 1, then we have 2 times 1 plus 4, which is equal to 2 plus 4, which is 6. Now if these are equivalent expressions, then when this is x is 1, this should also be 6. Let's test it out. So then we'd have 2 times 1 plus 2, which would be 2 times 3, which equals 6. So check. We got the same value. And this will work out every single time. You can choose, no matter what value of x you choose, these two expressions will give the same value. So in other words, when you evaluate these two expressions, they'll give you the same value every single time, no matter what value of x you choose. And that's what makes them equivalent. Now these expressions are not equivalent. They're close, but they're not quite equivalent. If you just kind of like get unlucky and choose a value like x equals 0, you might get tricked into thinking that they're equivalent, but they're actually not. So then if we choose x equals 0, we'll get 2 times 0 minus 5, which is equal to 0 minus 5, which is equal to -5. And then over here, if you put 0 for x, we would have 0 minus 5, which is equal to -5. So you can see that these two expressions produced the same value when x is equal to 0. But if you choose a different value, like 1, let's see what happens. If x equals 1, then we have 2 times 1 minus 5, which is 2 minus 5, which is equal to -3. Now over here, if we have 1 minus 5, that equals -4. So these two expressions did not produce the same value when x was equal to 1. So these expressions are not equivalent, because if they were, they would have to produce exactly the same value for all values of x. No matter what value of x you choose, those two expressions would have to produce the same value. All right, I hope that helps put some pieces together. Thanks for watching.